Hi, this is a brief lesson on maximum and minimum problems, that is optimization in Calculus 30. So oftentimes in real life, we want to maximize certain quantities, that is profit, revenue, maybe we want to maximize the area of a poster given some material, or the volume of a box given a certain amount of material. We want to minimize things in life too, like risk or expense, cost, the material used for, like I say, a specific volume. If you're given a volume and you want to know how much material you can get away with using just a minimum amount of material for that volume. So I just do a graph here in class about, just representing a situation where you have your profits here, right? You're going to measure your profits over here, and these would be, if you're manufacturing something, just units of something that you're manufacturing. So let's just say, for example, that if you create or manufacture a relatively low number of units, your profit will be at this point. There will be a point where you can make a certain number of units that will maximize your profit. And of course, the maximum profit is represented right here, and it's associated with this number of units. So it makes sense that if you make too many units that you can't sell, your profits start to go down as well. And so this is a situation where we have a clear kind of winning combination here, right? The number of units you're going to make to maximize your profit. And so these kind of questions are leading us to solving real life problems like this, where we can calculate, okay, so given certain parameters, how many units should I make to maximize my profit? And the parameters might be, in the form of this, some sort of a function here that you can create. So we're going to do a real easy question here, and I'm going to also just show you some on the side here. I'm going to show you some steps that you can use here. Now I realize I got to shrink this a little bit so you can see it. But anyway, so the steps to solving these questions are on the side here. And these are the steps you want to kind of follow through many of these optimization problems you'll find in Calculus 30. So here's example 1. It says find two positive numbers whose product is 10,000 and whose sum is a minimum. Okay, so here we go. This right here is the optimization part. We want to minimize the sum. Okay. So the first step is you want to set up some sort of relation for the quantity that you're trying to optimize. And when I say optimize, I mean either maximize or minimize, depending on the question. So obviously we want to optimize the sum, so I'm going to say, what does the sum equal? Well, in this question, it's just the sum of the two numbers, two positive numbers who have a minimum sum. So let's make the numbers x and y. So that's what I'm trying to minimize right there. So that's the first step. Set up a relation involving the quantity you want to optimize and the other related quantities presented in the question. So these are the two numbers. There's the sum. I'm trying to optimize the sum right here. The second point, the second step here is we want to write this now relation as a function of one variable, and this is where we use the extra information in the problem. And so how do we know what numbers I can make here? Well, a minimum sum, just what are the two smallest numbers you can think of? No, it has to be numbers that also have a product of 10,000. So over here you would say, well, we also know, and this is part of the restriction here in this question, is that x times y has to equal 10,000. And so how does that help us? Well, if we solve for one of the variables, we now can write this initial relation as a function of just one variable. So watch this. If I know that y in this question equals 10,000 over x, then guess what? I can substitute 10,000 over x in for y. So now it becomes x plus 10,000 over x, which means that this is now a function. And a function is really good because we want to find local max or mins, and we want to be able to find out, where those occur at which x value. So the way we set this up is the x that we've got in this new function is one of the numbers. You have to remember that, one of the numbers. A lot of arrows there, I guess. All right, so step 3 says find the derivative of the new function. All right, no problem. We know how to do that. Derivative of x is 1 with respect to x, of course. And then here we have the derivative of the top times the bottom, which is going to be 0, minus the top times the derivative of the bottom, which is going to be 10,000, over the bottom squared. That's the quotient rule. If you wrote this as 10,000 x to the negative 1, you could use the power rule. So that becomes this, 1 minus 10,000 over x squared. So that's our derivative right there. Okay, find the derivative. So we've done step 1, step 2, step 3. And these are the steps you're going to follow for every question, like this. Number 4 says identify critical numbers. Okay, understanding that the local max or the local min, in this question we're looking for a min, will occur at a critical number. And how do we do that? We set the derivative equal to 0. Like this. So we have 10,000 over x squared equals 1. That's 10,000 equals x squared. X equals plus or minus 100. Now, we are looking for positive numbers in this question. If you recall, the question says to positive numbers, so we can reject the negative possible solution here, and we have a critical number at x equals 100. Just one critical number in the domain of this question. So that is great. That is great. This is our critical number. That means that if we have a max or min, it's going to happen at this number, and it looks like 100. So what I want to do is I want to find the other quantities in the question, and now that brings us back to, remember this, y is related to x because x and y have to multiply to 10,000. And so y is actually 10,000 divided by 100, or 100. So x is 100 and y is 100. Okay, so check if necessary. Step 6 says, check if necessary, because the question said, what are the two numbers? So it looks like we have them, but let's check. Let's see if this critical number and the quantities, both quantities now that we've found, check to see that they make sense. Okay, well, the numbers have to multiply to 10,000, and we want a sum that is a minimum. So think of other numbers that multiply to 10,000 and just do a quick check. Just say, hey, can I find a sum that's smaller than 200? Because it looks like the sum is 200, right? And because the numbers are 100 and 100. So let's think, well, 5,000 times 2. Okay, the sum there is 5,002. That's far more than 200. 2,500 times 4. Well, that's 2,504. Okay, so you're seeing that, you know what, maybe we got something going on here. So this looks to be a minimum. And so we've just checked mentally, whatever, that this is logical. And so the answer to the question, you want to state the answer to the question and make sure that you answer the question. We'll look back to the question. Don't say, the answer to the question is a sum of 200. I'm done. No, that's not what the question asked. Another question might ask for the sum, but this question asks for the numbers. So make sure that you identify the answer to the actual question, circle it, show all your work, and you're done. So that is sort of the big picture here. All those steps, 1 to 7. You might want to take a look at that, and that's working through this problem using optimization methods here in calculus.